when we, I'm not going to record when we do discussion, just so people feel very comfortable and you don't have to worry about what you have to say about things out on YouTube. So, and I know I'm behind. I haven't put up the lectures for this week. I plan to do that this afternoon. So we were talking about the various types of error, and we were talking about, sort of the implications of how we do research and things like that. So one of the things we look at is statistical significance, right? We've got this magic P is less than 0.05 that we've arbitrarily decided means something is important or significant. But even if results are statistically significant, that doesn't necessarily mean that it means anything, right? If you've got a big enough sample, you could have statistically significant difference between a group that scores 31 on a depression inventory and a group that scores 30 on a depression inventory, right? And like, is that actually meaningful in someone's life? Maybe not. And so that's where we want to look at clinical significance, which is, does it make a difference in the real world? So if we were treating a disorder, does the difference we find statistically actually mean symptom reduction, improved quality of life for that person? Another aspect of hypothesis testing that is often overlooked is effect sizes. So again, we can say two variables are significantly related. They meet this magic P is less than 0.05, but again, does that mean anything? How big is that relationship? Effect size lets us know how large that difference actually is. There are many different statistics we can use to calculate effect sizes. One is just the correlation coefficient, or R. This is a measure of effect size. You can also turn experimental data into an R if you wanted to look at it that way. But with R, it can be difficult to interpret what those differences mean. Another way that we do it, and again, this kind of shows you how sometimes what we do in science is arbitrary, right? Is that we can take R and square it. And you'll see this when you do regressions, where it's just more complicated correlation technique. This gives you the percentage of variance explained by the result. And as you can see from my air quotes, like, what does that actually mean? Funder really doesn't like this. He calls it confusing and misleading. And then there's another variable called Cohen's d that is very often used. It's sort of the standard for effect sizes. And it's comparable to R, but it is on a metric that seems to make more sense to most folks. And so it's like the difference between means divided by a standard deviation. And again, you can take any type of stats, correlation coefficient, a path coefficient in a model, an ANOVA, and you could turn it into a D. Then there's the binomial effect size display. This involves using a table, and it tells you how much of an effect an experimental intervention is likely to have and how well you can predict an outcome from individual measurement of difference. Funder explains this in great detail. This is not something I've ever seen used in a publication. I mean, I think it's sort of like a pipe dream for people who love stats. So I would say, don't worry about this too much other than like knowing that it's a table in a complex method. Another thing we want to consider is ethics of research. So one issue we always want to consider is how that research, those findings will be used or potentially misused, right? So for example, when I was in grad school, we had a sample where it looked like one of the existing measures just wasn't working for one group. Well, that's really important to report, right? Because then we need to say like, hey, we shouldn't be using this measure with people who aren't white, basically, right? But there are other times where you might find like a racial or a gender difference. And if you publish that, people might use it to justify their biases. And so we need to kind of think about those things. Another big problem is fabrication or manipulation of data. This is obviously unethical, right? You shouldn't just make up your data. And yet there are multiple cases where this has happened. The most famous is the case of Andrew Wakefield. So for years, people still do this, even though it's been retracted, but people cited this study from 1998 by Wakefield to say that the measles, mumps, rubella vaccine, MMR vaccine, caused autism. And it's used to champion not vaccinating children. That's bled over into other vaccines, including the COVID vaccine. Jenny McCarthy is one of the big celebrity people of this, but even celebrities you would think would be kind of intelligent or very intelligent, like I'm gonna mess up her name, the woman who now hosts Jeopardy. She has a PhD, but she's anti-vax. I don't understand. His study, Wakefield's study, was not approved by an IRB or any kind of ethics committee. And he subjected children to invasive procedures, including at his own son's birthday party, he took blood samples from the kids. I'm pretty sure he didn't get parental consent. So you can imagine, here's your party favor bag, and also I need some blood. What? Right? Also, he literally manipulated and fabricated data. So the Sunday Times of London did an investigation. And they said, however, our investigation confirmed by evidence presented to the General Medical Council reveals that in most of the 12 cases that Wakefield said they got their MMR and then they showed signs of autism. The children's ailments as described were different from those in their hospital and general practitioner records. Although the research paper claimed that the problems came on within days of the shot, in only one case did medical records suggest this was true. And in many of the cases, medical concerns had been raised before the children were vaccinated. Hospital pathologists looking for inflammatory bowel disease reported in the majority of the cases that the gut was normal. That was another thing he was trying to argue. This was then reviewed, and the paper that was published was shown as abnormal. So he just made shoes up. He just put his data the way he wanted it to look. And people base decisions and still base decisions on this to this day. Whenever someone who is ethical has tried to study this, there is no relationship between autism and vaccines. And then side note, if we're talking about ethics, autism isn't a death sentence, right? It's really problematic to me that people would rather their kids potentially die from these lethal preventable diseases than to get into the be essentially neurodivergent. That's really problematic and stigmatizing and ableist, right? So that's just a whole other thing. Another quick example is, some of you may have heard of me talk about this in other classes. Some of you may have read about this. So there is a psychologist within my own field called Brian Wansink. He's actually the brother to our Dr. Craig Wansink on this campus. I don't think this implicates our Wansink in any way, shape, or form. But he was found to be fabricating a bunch of his data as well. And he had sort of groundbreaking research about food consumption. So I think 7 or 8 of his papers have been retracted. It's very rare for a paper to be retracted. Typically, they'll put in a correction if something's wrong. But to be fully retracted is super, super rare. So yeah, don't be unethical if any of you decide to go into research. It ends up being really bad for all your co-authors who don't know you've done this. Yeah. Another issue up for debate within the ethics of research is deception. So some argue that deception is necessary to test some things. This would be telling participants you're doing one thing when you're really doing another. But what the real big issue is within psychology that we've seen ramifications of throughout the years is because everyone assumes psychologists are using deception, it leads to mistrust by participants. And so even when there is no deception, participants are often trying to figure out what the psychologist is really doing or really testing, right? And then you're just not getting accurate results. And then just a cute little cartoon about some of the concepts that we discussed here. any questions about this before we go to our activity? Awesome. Well, I'm gonna stop share and I'm gonna go ahead, actually, you know what? Stop the recording.